talked about Friday was that inverses give you an angle. And if I'm looking at this, I know tangent inverse of 3 halves represents some angle. I'll just call it theta. And I'm asking you to find sine of theta. Which that wouldn't be any big deal if it were an angle I knew. But do I know when tangent is equal to 3 halves? No. Okay, so if we can't use a calculator and it's not an angle we know, we're going to draw a picture. Tangent inverse can be in which quadrants? 1 or 4. But since 3 halves is positive, I know I'm in quadrant 1. So if I do a triangle in quadrant 1, tangent inverse of 3 halves, what that means is tangent of that angle is equal to 3 halves. So we know tangent is opposite over adjacent. Could we find the missing side now? 2 squared plus 3 squared equals c squared. Hypotenuse is always positive, so that missing side is the radical 13. So it turns out I don't actually have to know the angle, because all I'm asking is sine from that angle. And I know sine is opposite over hypotenuse. So that would be 3 over the square root of 13. Or 3 radical 13 over 13. So this is really just using the definition of what an inverse is. It's finding an angle. It wasn't an angle we knew, so we could draw a triangle from that angle and then evaluate sine from that. Does that make sense to you? So we'll do one more like that, and then that'll be the end of section 1. I want tangent of cosine inverse negative 5 over 13. What quadrants can cosine inverse be in? Which one are we in? 2, because it's a negative. So this is an angle. All I'm asking you to do is find tangent of that angle. So cotangent inverse of negative 5 over 13 means, cosine inverse, means cosine of our angle is negative 5 over 13. Cosine is adjacent, so that would get the negative. Hypotenuse is positive. Missing side, you might recognize it, but if not, you could work it out. Is that side positive or negative? Positive, because we're going up. 1 squared 144 is 12. So now tangent of theta, opposite over adjacent, 12 over negative 5, or negative 12 is. Any questions on that? So that is actually the end of section 6.1. So I gave you this homework Friday. And I think I told you Friday you could do everything except 79. So you can do problem 79 now. This is due at the beginning of class tomorrow. Okay. Then I want to go ahead and do the 6.2 notes. We're going to do part of that section and then I'll finish it up tomorrow. Those I do not have a notes handout for, so you need your notebooks. So now, the next two sections, we are just going to solve equations that involve trig functions. It all goes back to unit circles. So if you have a unit circle with everything filled in, that might be a good thing to reference. If you are not comfortable with filling in a blank unit circle on a test, you might start practicing those now. I have plenty of copies that we can work on. The difference is, this question says solve 3 tangent theta minus the square root of 3 equals 0. If I look at this problem, does it say tangent inverse in the original problem? No. That means I am talking about every time on the circle it happens. So when the original problem starts with an inverse, that's when we immediately knock it down to only 2 possible quadrants. If I just have a regular trig function, we're dealing with the whole circle. So if I want to solve this, how would you get the tangent theta by itself? And then we can divide our 3. So tangent theta is radical 3 over 3. Okay, it's not an inverse, so we're looking at every quadrant when tangent is equal to a positive. When is tangent positive? So I will get 2 answers here. Part A is just telling me, give me the answers between 0 and 360 degrees. So we're looking for degree measures. In quadrant 1, when is tangent radical 3 over 3? What is my reference angle? When does that happen? 30 degrees. So in quadrant 1, 30 degrees is 30 degrees. In quadrant 3, 180 plus 30 is 210. Part B says for all solutions. So we know the graph of tangent looks like this, right? But it keeps going. All these trig functions just keep repeating. So isn't it going to equal radical 3 over 3 more than just 2 times? Yeah, it'll keep going. Every time you go around the circle, you're back to another point. How many degrees does it take to go all the way around the circle? So if I say all solutions, you just take each of your original and you add 360 degrees, and we just pick a letter. I usually use K. But you need to specify what K is. So at the end, I always put this. It means K. This curved D means is an element of the double barred Z. Do you remember that means integers? So that means K is an integer value. So it's 1, 2, 3, -1, -2, -3. It's not allowing me to add a fraction of 360. I have to do the entire thing. All right. Questions there? Now you might see it written differently. You have to have an equivalent answer on these. But technically, if you think about it, 30 degrees is here, 210 is here. So if you're at 30, plus 180 is here. Plus 180 would take you back here. So in the book, they always do the most concise. So the book, if you were looking, they would have said 30 degrees plus 180 degrees K. Just saying, because those are 180, or every 180 degrees, you get another solution. I don't care as long as you have an equivalent solution. Is that one okay? Let's look at this one. 2 sine theta plus 1 equals 0. So what would we do first? Again, these aren't inverses, so we're looking every time on the circle when sine is negative. Inverses can only have one answer. Otherwise, we can have multiple. When is sine negative? Reference angle. this side 1/2. So 30 degrees in quadrant 1, or quadrant 3, so 180 plus 30 is 210. In quadrant 4, 360 minus 30 is 330. If you're looking at your circle at 210 and 330, is sine, the y value, equal to negative 1/2 at both of those? If I say all possible solutions, all you have to do is take each of those and add 360 degrees K. Unfortunately, every problem you do need to tell me what K is. And you can write it out in words or just use the symbols. It's just telling me K has to be an integer value if you're going to add it to both. So far, so good. Let's try to do a couple more. We have cosine on both sides, but you don't want to divide by it. It's just kind of like if you had, x squared equals x. You don't divide the x over. You get all the variables on one side. Problem is, if you divide it over, you will lose the solution when it's equal to 0, so you won't get the total answer. So if I add over my cosine theta, so we're just solving an equation. When I look at this, we have two terms. Both terms have a cosine theta, so we're going to factor that out. So now I have two things multiplied that equal 0. So just like when we have fraction and quadratics, if you got to x squared minus x equals 0 and you took out your x, we set each of those equal to 0, right? That's what we're going to do here. So we need to find when cosine is equal to 0, and when cotangent theta plus 1 is equal to 0. Okay. When cosine is 0, if you think about your unit circle, cosine is the x. When is x 0? I asked for all the answers between 0 and 360, so we don't have to do the plus 360k on these, and we are in degrees. Okay, over here, this is when cotangent is equal to negative 1. In which quadrants is cotangent negative? Referencing, when is cotangent 1? Tangent is 1, which is 45 degrees. So 45 degrees in quadrant 2, so 180 minus 45 is 135. In quadrant 4, 360 minus 45 is 350. Tomorrow we will do more. saw back when we were doing proofs that we can factor with trig functions, just like we can with our normal variables. So I have 3 sine squared x minus sine x minus 2. It's the same thing as if I'd had like 3x squared minus x minus 2. What would you do to factor that? Yep, maybe our slip and slide. Multiply our 3 down. Factor it. Sine squared breaks into sine. Multiply to negative 6 and add to negative 1 would be a negative 3 and a positive 2. Now what? Divide our 3 back. You can even leave it like this, so sine x minus 1 equals 0, and sine x plus 2/3 equals 0. So now we have to solve these. So I need to know when sine is positive 1 or negative 2/3. In my problem, it told me over the interval 0 to 2 pi. So I don't have to do all possible solutions, but the 2 pi tells me I'm in radians. So think about your unit circle. Sine is the y. When y is 1, that is pi over 2. Okay, over here. If sine is negative, we know sine is negative in quadrant 3 and 4. Reference angle. Do we know when sine is 2/3? No. So we're going to use our calculators. Alright, so make sure you are in radian mode. And then we need to do sine inverse of the positive 2/3. I told you Friday, always put in the positive. I get 0.7297. So to put that in quadrant 2, quadrant 3, you do pi plus that. So if I type in my calculator, pi plus 0.7297 gives me 3.8713. In the fourth quadrant, we do 2 pi minus 5.5535. The nice thing about these, they're equations. You can always plug them back into the original to check. Sometimes we get nice points off the unit circle, but if it's one we don't know on the circle, then we use the calculator and do the inverse. So, the rest of class is time to work. Finish the 6-1, that's due at the beginning of class tomorrow. Here is the homework for 6-2. If you don't like the every other odd, I can write it out. But you can start this and you can probably get through a decent amount. Tomorrow I'm going to do more examples from 6-2. So not necessarily anything new, just more practice. And then we'll have some time to work on it towards the end as well.